Hey guys, today we are looking at 4.2 and we're going to talk about how to find the real zeros of polynomial function if you cannot factor it. So we talked about polynomial functions last class period. We talked about the different characteristics. We talked about if you already know what the zeros are, how you could write an equation. But now we're going to talk about if we have an equation, how could we find the zeros? So first we're going to start with the remainder theorem. It says, suppose f is a polynomial function. If f of x is divided by x minus c, then the remainder is f of c. So we're going to get some practice with doing some division. If you remember from Algebra 2, you could do log division or synthetic division. So we're going to review synthetic division here. So if we're looking at synthetic division, remember we've got our box up here. And if I have x minus 2, that would mean that x equals 2. So in our box, we're going to put that 2. Then our polynomial function is x cubed minus 5x squared minus 6. So we are going to list out our coefficients next to the box. So we have 1x cubed. We've got negative 5x squared. We've got 0x and negative 6. Remember to put that placeholder where that x would go. And then we're going to do our synthetic division. So that means we're going to bring down the 1. We take whatever's down under the line and multiply it by what's in the box. So 1 times 2 is 2. Then we're going to add straight down. So negative 5 plus 2 is negative 3. And then we repeat that process. So negative 3 times 2 is negative 6. Add straight down to get negative 6. Negative 6 times 2 is negative 12. And add straight down to get negative 18. So what that is telling us is that f of 2 is negative 18. And you could check that by plugging 2 in for your x's up here, and you would see that you would get negative 18 when you plug 2 into the function. Okay, let's check our next one. If we have x plus 4, that means that x equals negative 4. So I'm going to put negative 4 in the box. It's the same polynomial, so we have the same numbers listed out, 1, negative 5, 0, negative 6. So from here, I'm going to bring the 1 down. 1 times negative 4 is negative 4, so we get negative 9. Negative 9 times negative 4 gives me a 36. 36 plus 0 is 36. 36 times negative 4 is negative 144, and when I add them, I get negative 150. So f of negative 4 would be negative 150. So the reason that we would use this is that we would want to get, instead of like a negative 18 or negative 150, we would want to get that it's 0. So that's where our factor theorem comes in. The factor theorem says, suppose f is a polynomial function, then x minus c is a factor if and only if we end up with 0. So f of c is equal to 0 means that it's a factor, or it's a factor means that you would get 0 when you plugged it in to the equation. So we're going to do some more synthetic division, and if we get that that last number is 0, then that means that it is a factor. If we get a different number, that means it's not a factor. So let's try it here. I'm going to say x equals 2 because I have x minus 2. So my number that goes in my box is 2. Then I have my polynomial right here, x cubed minus 2x squared plus 3x minus 6. So I'm going to have a 1x cubed, negative 2 for the x squared, 3 for the x, and 6 for the constant term. I'm going to bring down my 1, multiply it by my box, so I get 2. Negative 2 plus 2 is 0. Multiply that by 2 and get 0. Add to get 3. And 3 times 2 is 6. Oh, my negative disappeared. Negative 6 plus 6 gives me 0. So since that is 0, that means that f of 2 is 0. And yes, this is a factor. Okay, x plus 1 would mean that x equals negative 1. So in my box, I'm going to have a negative 1. Then my numbers listed across would be 1, -2, 3, and that -6. I'm going to bring down my 1. 1 times -1 is -1. So I get -3. -3 times -1 is a +3. So 3 plus 3 is 6. 6 times -1 is a -6. And when I add here, I get a -12. That means that f of -1 is equal to -12, and this is not a factor. So you can find if they're factors by using your synthetic division. But the next question is, well, how do I know what numbers to use for synthetic division if it's not like example 1 and example 2 where it says use these? Like it gave us very specifically x minus 2 and x plus 4 in example 1 up here. And it gave us very specifically x minus 2 and x plus 1 in example 2. So that's where our rational zeros theorem comes in. This says let f be a polynomial function of degree 1 or higher. So it gives us an example of a polynomial function. It says a sub n of x to the n, and then a sub n minus 1 of x to the n minus 1. That's a really like fancy way of just saying a polynomial function, where you've got your leading term over here, and over here you've got your constant, the one that doesn't have an x on it. Okay, it says if p over q in lowest terms is a rational zero of f, so it's telling you that that would be a zero, then p, the top part of the fraction, must be a factor of a sub 0, so it must be a factor of our constant term. And q, the bottom of the fraction, must be a factor of a sub n, which is the leading term, the coefficient of the leading term. So it narrows it down from it being any possible number to being these specific possible numbers. So the potential rational zeros are any fractions that fit into these categories. So if I'm looking at example 3, my constant over here is 4, and my leading coefficient is 2. So if I'm looking at that 4, oops, wrong color, all of my possible factors of 4 are 1 times 4 and 2 times 2. Then my leading coefficient is 2, and all the possible factors of that are 1 times 2. So this is my P, and this is my Q, and I'm going to make every possible fraction that is P divided by Q. So I'm going to start and I'm going to look at this 1, and I'm going to divide it by both of my Q's. That means that I would have 1 over 1 and 1 over 2. So that's using this one right here. Okay, then for the next one, we're going to move on to 2. That's right here. So now I would have 2 over 1 and 2 over 2. Then we can move on to this 2. If it's the same number, I actually don't really need to repeat it again, so I'm not going to write those again. And so instead, I'm actually going to move on to my 4. So then I'm going to have 4 over 1 and 4 over 2. Now the thing is, all of these could be positive numbers or negative numbers, so I am going to put in front of them plus or minus for every single one of them. And I do have to simplify them. So 1 over 1 would just be plus or minus 1. Then I have plus or minus 1 half. 2 over 1 would be plus or minus 2. And then if I have 2 over 2, well, that gets me back to 1. So I don't need to repeat it. 4 over 1 would be 4, and 4 over 2 would get me to the 2 as well. So these would be all of my possible numbers that I would try my synthetic division with. So let's do some examples where we actually go through and try it. So right here, example 4 says find the real zeros of the polynomial function and write it in factored form. So I'm going to start with that same P and Q. So over here, I've got 2, and over here, I've got 3, technically negative 2. So if I'm looking at 2, all of the factors are 1 and 2. Then for 3, it's 1 and 3. So remember, we're doing all of the blue numbers, all of the P's divided by all of the pink numbers, all of the Q's. So the first ones that I could do are the ones divided by those 1 and 3. So that could be plus or minus 1 over 1 or plus or minus 1 over 3. And then the next ones are the 2's over those. So plus or minus 2 over 1 or plus or minus 2 over 3. So I have plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3. So now I just need to pick numbers and see if they work. The first one I always go for is 1. It's an easy one to try synthetic division with. So let's try 1. I'm going to put 1 in my box, and I'm going to list out my coefficients. So 3, 4, -5, and -2, and see if they work. So bring down my 3. 3 times 1 is 3. 4 plus 3 is 7. Times 1 is 7. Then we get 2 times 1 is 2, and we get 0. So that works. So that means one of my answers is x equals 1. Okay, we could try a -1, see if that works. And when you try this, now you can use the new coefficients that you get right here. So remember, this is technically your remainder. And so this would now be 3x squared plus 7x plus 2. So you could keep doing synthetic division, or honestly, you could try and factor that too and see if you wanted to factor it. If I wanted to factor it, instead of just trying, guessing, and checking with synthetic division, remember we would do 3 times 2 on top of my big X. That would give me a 6, and then a 7 here. So 3 times 2 would be the 6. And then if I need to multiply it to get 6 and add to get 7, I would do 6 times 1. Split my middle term, so 3x squared plus 6x plus x plus 2. I can take out a 3x up here, which gets me x plus 2. A 1 back here, which gives me x plus 2. The 3x plus 1 and x plus 2. So the x plus 2 means x equals -2 is another one, which if you look, that does fit into our factors over here. And then if I have 3x plus 1, that would mean x equals -1/3, which also does fit into our list of factors. So those would be all my zeros. And then if I would write it in factored form, I would have that 3x plus 1, the x plus 2, but then I would also need to put in that x equals 1 as a parentheses as x minus 1. Okay, and then last one, let's do the same thing. I'm going to start with my p's over here, my q's over here. Both of them are 2, so it's just 1 times 2 for both of them. If I start with the 1's over here being divided by the 1 and 2, I would get plus or minus 1 over 1, plus or minus 1 over 2. And then move on to the 2 being divided by those. I would get plus or minus 2 over 1 and plus or minus 2 over 2. So plus or minus 1, plus or minus 1/2, plus or minus 2, and 2 over 2 gets me back to 1. So I've just got those three options this time. And let's try 1 again. So I've got 2x to the fourth, negative 1x cubed, negative 5x squared, 2x, and 2. So bringing down the 2, 2 times 1 is 2. Then I get 1. 1 times 1 is 1, so I get a negative 4. Negative 4 times 1 is negative 4, so I get negative 2. Negative 2 times 1 is negative 2, which gives me a 0. So we're good, and x equals 1 is one of my answers. But notice now, if I were to write this, this would be 2x cubed plus x squared minus 4x minus 2, because we started with a fourth, so this would start with a cubed. You remember that from Algebra 2. So we're not quite down to something we could factor yet. So we need to try something else. If you try different numbers, you'll notice that negative 1 doesn't work. You could try 2, it doesn't work. Negative 2 doesn't work. What's going to end up working is negative 1/2. So I'm going to do negative 1/2, and I am going to use these numbers. So the 2, 1, negative 4, and negative 2. I don't have to go back to the original numbers. I can go with these numbers so that I can get down to a quadratic that I can factor. So I'm going to have 2 times negative 1/2, which is negative 1, gives me a 0. So when I get that again, gives me a negative 4. Negative 4 times negative 1/2 is a positive 2, which gets me a 0, and that works. So x equals negative 1/2 is one of my answers. And now I'm down to 2x squared plus 0x minus 4, or just 2x squared minus 4. And I can't necessarily factor that with my big X, but I can go ahead and solve that. I could divide everything by 2. So I get x squared minus 2 equals 0. Then I can add 2 to both sides, so x squared equals 2. And square root both sides, so x equals plus or minus the square root of 2. That would be my answer. If we talk about our answers, if we have it to the fourth, we should have 4 answers. So we've got 1, 2, and then the plus or minus gets us 3 and 4. That kind of checks out there. If we want to write it in factored form, if I have x equals 1, that would be x minus 1. X equals negative 1/2. You could write that as x equals negative 1/2. Let me rewrite that a little bit nicer. X equals negative 1/2. I would multiply both sides by 2 to get 2x equals negative 1, and then add the 1 over. So it would be 2x plus 1. And then we do have the 2x squared minus 4 that can come in right there as my other factor. So there are my factors, writing it in factored form. Okay, let me know if you guys have any questions. Make sure you get started on your assignment, and you guys have a good day.